is now evidence for a planet which was formed roughly 1 billion years after the Big Bang, 13 billion years ago, is just absolutely unprecedented. All of the roughly 100-odd extrasolar planets that we know about today are in orbit around stars that are basically in the solar neighborhood. They are presumably stars that are no older particularly than our own sun. But in this case we have a star where we presumably could have formed not only a gas giant planet, but perhaps also a habitable planet where life could have arisen and died out long ago, well before we came along to the galactic party.
The planet is in an ancient globular star cluster and is part of a system that includes a fast-spinning pulsar and a white dwarf star. Unlike previously discovered planets outside our solar system, which are all in our interstellar neighborhood, this planet is on the other side of the Milky Way galaxy. Its existence and age imply that planets formed very early after the Big Bang and may be far more abundant throughout the universe than previously thought. Glowing ghosts in the sky, dying embers of burnt-out stars, or nurseries where new stars are born. Like no other observatory, the Hubble Space Telescope shows us the secret lives of stars, from cradle to grave. In early 2002, a distant star in an obscure constellation suddenly flared up to become 600,000 times brighter than our Sun. It has since faded, but Hubble has been watching its light echo off the gaseous clouds surrounding it. The stellar blaze is lighting up the gas shells surrounding the star, which were ejected in earlier eruptions. The light from the recent outburst travels to the shells and is reflected to Earth. This indirect path means the direct light arrives months earlier than the reflected light. Hubble is using the echo to create a unique three-dimensional probe of the star's environment. Stars are born in colossal cauldrons of gas and dust. Hubble recently imaged the star-forming nebula M17, showing us a blaze of baby stars born in shock waves created by older stars dying in gigantic explosions. The Helix Nebula is one of the largest in the stellar neighborhood.
When stars like our Sun, or slightly more massive than our Sun, die, they lose lots of their outer envelope in a massive stellar wind. And this massive stellar wind enshrouds the star in a dusty molecular-rich cocoon, and then it coasts away from the star. And then as the core of the star is revealed, it photoionizes this outer envelope and illuminates it, making it glow, and it appears to us as a planetary nebula.
The Hubble images of the helix have yielded some surprising results.
What we see when we look with the Hubble Space Telescope is that some mechanism has operated to trap about 1/2 of all of the material that's been ejected by the star into these tiny knots, which are just a few times the size of the solar system. An entirely unexpected result.
And we could only have gotten it from Hubble. In 2003, Hubble used galaxy cluster Abell 1689 as a natural telescope to see images of galaxies far behind it in the ancient universe.
Clusters of galaxies like Abell 1689 can be thought of as cosmic telescopes, and these telescopes magnify the universe that we see behind them. There are two things that we can do with this magnification. We can get a highly magnified view of galaxies forming within the first 1 to 2 billion years of the beginning of the universe, and we can use the magnification of these galaxies to understand the geometry of the universe.
Hubble's exquisite sharpness, combined with the behemoth natural lens, reveals remote galaxies that were previously beyond even Hubble's incredible reach. Some of the faintest objects in the image are probably over 13 billion light-years away. Gravitational lensing also helped Hubble spy a mysterious arc of light far away in the early universe. In deep sky images, astronomers noticed a mysterious red arc of light behind a distant galaxy cluster. Astronomers determined that the mystery arc is actually a massive and incredibly bright cluster of newborn stars that has had its light magnified and distorted by the foreground galaxy cluster. The star cluster is over 12 billion light-years away and contains over 1 million brilliant and intensely hot stars. It is a glimpse of the early universe when furious firestorms of star birth blazed across the cosmos. In 2003, Hubble teamed up with the Chandra X-ray Observatory to deliver the goods.
The GOODS survey, the Great Observatory's Origins Deep Survey, is the most ambitious survey of the distant universe yet undertaken with Hubble. It targets an area of sky about 60 times the area of the original Hubble Deep Field observations that were taken back in 1995, but going to about similar depths. So we can study the same kinds of objects, we can actually study more distant objects, and we get many, many more of them. And what we're doing is trying to target the earliest phases of galaxy evolution back when the universe was 1, 2, 3 billion years old.
When one galaxy collides with another, chaos reigns. In Stephan's quintet, a nearby galactic gang of 5, galaxies are battling it out like tag team wrestlers, crashing and smashing into each other from every direction. It's a scene of mayhem on a colossal scale.
The galaxies are colliding with each other, and there have been many